Oh, all right. Okay, let's see. Antoinette, Megan, placebo control, respond bias, placebo effect, placebo effect, placebo effect. Placebo effect, right? Placebo effect. That's it. All right. Next we're gonna talk about three types of experimental design. First one, a complete randomized design. Remember, it's similar to what comparative, right? Randomized design. The second one will be, I keep forgetting. I keep let's try to scroll down with the mouse. The second one will be randomized block design, and then the third one is match pair design. Okay, so those are three experimental design we're going to learn today. Complete randomized design. So like the diagram show you, first we have all subjects, right? So what we're gonna do is we're gonna randomize them, right? You want to put them in treatment, you had to randomize them. Everybody have a equal same chance of being picked for each treatment, for each group. So we have three group here by randomization, and then we're gonna assign group one to treatment one, and group two to treatment two, and then group three to treatment three, and then we measure response for each group, and then we compare the results. Now I want you to read this problem and fill in the box, just like I did here, with context. Don't just do group one, group three. Tell me what is group one, what is group three. So fill in this box. I'll walk around, see how you do. Once you copy, oh, you can turn on your computer. It's in your slides in the Moodle page. I assume you finished drawing the diagram. I'm gonna walk around, see how you do things. Maybe you need help, let me know. Sean, let me know what you got. Which is, oops. All subject. So all 60 patient. Be specific, right? And then this box. And same thing with group 2, right? What about this one? Yeah. You pick in, you put them into a group by randomize them or randomly assign them into each group. Random assignment. And then this box. Good. X, how do I spell exercise? X. Have you guys tried acupuncture? I did. It works. I cannot speak for a scientific, proof, but it works on me. At least on me, it works. They yay long. They poke into my knee. It works. But there's no scientific. No, I don't think they done any scientific yet. And then treatment 2. Yeah. And then the box. Oh, what happened? Measure response, right? Oh, what do we do? What kind of measure response? Yeah, level of pain. So, yeah. See what word do I put in there? Measure level of pain due to carpal tunnel syndrome. And then same thing down here. What I'm gonna do, I'm gonna copy because I'm lazy. Duplicate that down here. And then compare response, right? Compare the maybe next time I'll try to print it out for you. Okay, randomized block design. So that is complete randomized design. It's very simple. Basically, you have a pool of people, randomly assign them into groups, put them in treatments, measure the response. Okay, that's it. Randomized block design, it's slightly more complicated. When you hear block, think of women and men. Because a block, what is block do is that it's a group of individuals that are known before the experiment to be similar in some way. So usually when we randomize user block design, we do on like women and men, because we have to sort of have two different physiology, right? Or even mentally, how we conceive things a little bit different, right? So block, think, I want you to think men versus women. on the exam, men versus women, that definitely block. A block is I talk about that. In a block design, the random assignment of an individual to treatments is carried out separately within each block. So that's why they call block design. Each group with each different, some sort of different way is being assigned to the treatment. And we measure separately within each block. Okay. So here is the graph of the randomized block design. It's slightly more complicated than complete randomized design. Right? So again, we have all subjects, and prior to the random assignment, we split them into two halves. Why? Maybe because one group is similar within that group, all the individuals similar to each other, and this group, all the individuals each other, but they kind of different, right? If you compare between the blocks. And then once you have two blocks or three blocks or how many blocks you need to be, you're gonna do random assignments. And now, right now, it's kind of look like what? Complete randomized design. Right? The only thing is adding is separate the two blocks. That's all. Then random assignments for groups. Each group received the treatment, and then measure response, compare the result block 2, compare result block 1, and then compare all together. For this one, I want you to fill out this one as well. You can draw that. Yeah, draw that down, and then, or you can look at your computer. Shiny app here. Shiny app. Install Green Shiny require installation update version of Shiny package. Do you want to install Shiny now? Under jobs. How many more do we have? Mhm. All right. So we random assign them. So once we have two blocks, what do? We random assign them, right? randomly assign or random assignment, randomly assign. Okay, this box. Yeah. Yeah, G1, I don't have space. So G1, 1/3 women. Oh, right, men first, 1/3 men. And then group 2, what? 1/3 men, right? And then group 3, 1/3 men again. All of them added to 1. And then women, same thing, right? Group 1 and within the woman block, 1/3 women. Group 2. Where's my thing go? One-third women. Group 3, 1/3 women. Good. And then what do we do with these randomly assigned groups? The next box. We add 1, add 2, right? We put treatment on them. So the 1/3 of group, the first group 1, 1/3 men is add 1, add 2 for the second group, add 3 for the third group. Same thing with women. And then this box, we compare result, right? Compare result in block men or block, in men block. And here, down here, we compare result in block women. And together we compare what's different between how men and women perceive the ad differently, right? All together. Okay. Expect something like this on the exam. Just one, I'll just pick one. I'm not gonna make you do all 3 types. So that this block design, when you have, if on the exam you see women, men, block design. Match pair design. Now, before I go into the diagram, I need to explain to you what does match pair mean. For the first 3, you don't have to know. If you want, oh, I'm sorry, for the first two bullet point there, you don't have to know, but you need to know the types of match pair design. There are 2 types. One is same individual. So each person or unit is measured twice and measure a response before and after treatment. Example, I'm gonna take me and you, we're gonna take our body temperature in the morning, and then we take the body temperature again at night and then compare. So each person being measured twice, right? Measure temperature in the morning, measure temperature at night. Only one person, but you do it twice, same individual, and a bunch of people doing like that, me and you, and then we compare the results. Match individuals, similar individuals or units are paired prior to the experiment. Each member of the pair receive a different treatment or the same response measure. The easiest example is somebody related to each other, mother, daughter, father, son, brother, sister. So say I want to compare my height to my mom's height, and I'm going to ask you the same thing. You ask what's your mom's height, right? And I'm going to come and then say daughter height of son height. And then over here we have mom height, right? Mom height. So here daughters, so Mimi, Antoinette, Bailey, Megan, right? Caitlin, and then all moms, right? And then we compare. So that is matched individuals. Right? You compare with somebody similar to you, which is your mom or your dad. Usually, what do you see between you and your mom height? Similar, right? You should be similar, unless your dad really tall. Then maybe you should take after daddy. or entirely somebody else. I'm not even going to do that. All right. So that's match pair design. So here is the diagram. All subjects, it could be similar individuals, or it could be same individual, it could be you and yourself, right? And then pair. You're gonna pair, if you pair with yourself, say pair, cell pair, right? Cell pair. Cell pair one, so Mimi, Antoinette, Bailey, etc. Right? So those are cell pair. Subject one is what? Subject one is, say, if it's same individual, it'll be what? Temperature in the morning. Right? And then subject two will be temperature at night. Oh, I'm so sorry. Treatment. Pair. Oh, sorry. Pair will be cell pair. And then subject one will be you. We say Mimi, and then sending pair to Megan, subject one still Megan, still Megan, right? Because you guys cell pair. And then treatment one will be what? Measure the temperature in the morning. And then treatment two is measure the temperature at night. Okay. And then you measure the temperatures, then you compare. So here is the example. A study involved 25 right-handed students and a device with different knobs, right-handed thread and left-hand thread. The response interest is the time it takes to move knob indicator to fix distance. The question of the interest is to access if the right-hand thread is easier to turn on average. Notice that in this example, each subject is his or her own match. So for the same individual, right? You got two hands. So that's your subject. Subject one will be left hand, subject two will be right hand. And randomization is performed with respect to order of which knobs are tested. Okay, so here right here, 25 right-handed students. Student one, these are pair one, pair two, you are cell pair. Student one, student two, and three, all the way to student 25. And then the pair will be student. The subject is left hand or right hand. And then treatment is you measure time. You turn the knob to the fixed distance, right? Then you measure times. I could have put one more box here. The treatment will be what? Turning the knobs, right? And then another box next to it say measure times. Then compare results. Let me tell you what to expect on the exam. I will never ever make you do the mesh pair design exam. But expect one of these. The block, the match, the randomized block design, and then complete randomized design. And one of those will be on the exam. You use scenario and then you fill in the box. I'll give you the box. I'll give you the diagram. Fill them in just like we did today. Do you have any questions? Okay. Almost done. Yay, almost done. Okay, so why do we do this? Why do we do control? Why do we do randomization and replication? Well, all of these here, all the reason we're doing all these is to reduce bias and look-in variable. The bottom line is reduce bias and look-in variable. Okay. The control is restrict the effect of look-in variable on a response, most simply by comparing two or more treatments. Randomization is randomization reduce what? Why do we randomize? The reason I don't let you choose the class, but I randomly assign you because what? Bias, right? Bias. Right. And then replication, you do the same experiment over and over again, see if you have the same result. Right? This happened to any research study. All right, statistical significance, you don't have to know it now. Is observed effect so large that it would rarely occur by chance is called statistically significant. How large is large enough? We'll find out later. Correlation is equal to causation. Now, let me tell you now, and remember this for the quiz. Correlation is not causation, right? Say the number of people who buy ice cream. No. The ice cream consumption in the summer, ice cream consumption is increased as well as the people get shark attack? Is eating ice cream causing shark attack? No, right? Just because in the summer it's hot because of the beach, right? In the beach there's ice cream, and then they swim, so they swim. That's shark. But there's a correlation, but there's no causation. For try it, we're not going to do it today. I want you to do it. It'll be on your quiz. So answer this as much as you can. It'll be easy. I'll give you the answer. You pick the correct answer. That's all. So the two right here will be on your quiz. See, I'll tell you 2 out of, I think 8 question or something, 8 or 7 question, I forgot. All right, that's it. Do you have any questions? No? All right, have a good night, and I'll see you Wednesday in person, okay? Because we have to take a quiz. Make sure you bring your laptop with you, or at least some sort of iPad.